it will treat it like a address. Okay, so please note, pointers can hold only addresses, and integer variables, they can hold only numbers. Okay, right. Now next, a pointer always hold an address. Size of all pointers irrespective of their data type is same. Okay, now you take a pointer of character type. Okay, it will be 4 bytes or 8 bytes depending upon the OS that we are using. Okay, depending upon it is 64-bit or 32-bit OS. Okay, the size of a pointer actually depends on the RAM size. Okay, actually depends on the RAM size. Why? See, bigger the RAM, the number of addresses is bigger. Okay, right. Now say suppose P RAM, if I have 4 KB RAM, okay, the addresses starts from 1 2 3 like that. Okay, so in the case of 4 KB RAM, what is the last address? 4096. Okay, right. In a case of 4 KB RAM, okay, the addresses is starts from 1 and ends with 4096. In the case of 16 KB RAM, okay, right, in the case of 16 KB RAM, the addresses start from 1 and ends with 65,536. Okay, right. So as you can see, when the RAM size is growing, the last address is also growing. Okay, so what I'm trying to say is the number of byte to store this 4096 is definitely lesser than the number of bits required to store this number. So as and when the RAM size is growing, the last address, okay, of the in the RAM is also a very big number. To store that big number, we need more space. Okay, right, and hence the pointer size might be 4 bytes, 8 bytes or 16 bytes. Okay, depends on the RAM size. Okay, I'm sorry. Now let's continue. So now this point, that is a 4 point, is very important. See, the size of all the pointers irrespective of the data type are same. That is, if you take a character pointer or double pointer or float pointer or int pointer, okay, all these pointers have same size. However, what is the size of a character variable? 1 byte. Integer variable 4 bytes, double variable 8. Okay, so the variables of different data types, they are of different sizes, but the pointers of different data types, they are all same. All are same. Why? What is the reason for that? The reason is they all hold only addresses. Okay, what is an address? It is one of the memory location in the RAM, in the memory, isn't it? So to store that address, okay, the space required is same. Okay, right, isn't it? By any type of pointer, by a pointer of any type, okay, when they are storing that address, they need same size of space in memory. Okay, I'm talking about the pointer variable space. Okay, the space required to store an address. Okay, a pointer of a specific data type, say int star, can hold the address of a variable of the same data type. Okay, so mean to say, if you take an integer pointer, it can hold the address of integer variable only. It cannot hold the address of a variable. Okay, right. So why is this? The reason is again the address of property, that is length or data length or size of a data type property. Okay, right. So now next, the operators we have already seen. These two operators I have already explained it to you. Okay, anyhow, let's discuss this again. The unary asterisk, unary star, okay, it is called as dereferencing operator, and it is also called as value at operator. Any of the two names is fine. Okay, right. It can be applied only to an address, nothing but a pointer, because pointer holds an address. Okay, then when star is applied to a pointer, that is nothing but an address again. Okay, we get the value present in the target address, in that address. Okay, so what we get when we use the star, when we can apply star only to an address. Okay, right, and when you apply star to an address, you'll get the value present in that address. Okay, very simple. In this example, I can apply star to 1001. Okay, right. I hope you're trying to understand. So I can say star 1001. When you say star 100, what you get? 10. Okay, right. So what is star? It is dereferencing. What do you mean by dereferencing? Going to the address and fetching the value present in the address. Okay, what do you mean by dereferencing? Fetching the value present in the address. What address? 1001 in our case. Okay, so 1001 is target address here that we have taken. So value at that address is 10. Okay, so that is what we get. Okay, right. Next is unary ampersand. Okay, it is called as address of operator. Okay, it is called as address of operator. It can be applied only to a variable including pointers. It can be applied only to a variable including pointers. Okay, so I mean to say, since pointer is also a variable, right, so we can apply ampersand to pointers also. In other words, ampersand can be applied to any variable. It might be pointer or any other pointer, I mean any other variable. Okay, and when you apply ampersand to a variable, what do you get? You'll get its address. Example, come to this. See, when I say ampersand, num, in this case what I get? 1001. That's very simple. Okay, right. Now I hope you are understanding here. Okay, okay, fine. So let's continue. Memory representation of a pointer. Now we are taking again one example here. How it looks like in memory is what we are learning. See, we are taking an integer variable, say its value is 25. Okay, name is var. Okay, its address is 5001. Now what I'm doing, I'm declaring a pointer. How to declare a pointer? You have to use asterisk. Okay, the reason is, please note, int here 25. What is the data type of 25? It is int. What is the data type of var? It is int. But what is the data type of 5001? It is int star. What do you mean by int star? The address in which integer value is present. The address in which an integer value is present. So please note, in 5001 we have an integer value present. Okay, so 5001 here is an address in which integer value is present. The data type of this 5001 where int value is present is int star. So now we want to store this. Okay, see, when I want to store a value of type int, the variable data type should be int. That's what we have done. Okay, so 25 is of type int and var is also of type int. That's very simple. Okay, now 5001 is a data of type int star. So we need a variable of type int star to store it. Very simple. So ptr we have taken of type int star, and ampersand var is 5001, which is also int star. 25 is int, var is int. Ampersand var is 5001, its data type is int star. ptr here, its data type is int star. Okay, right. So I hope you have understood this point. Okay, so ptr is holding the address of the variable var. In other words, ptr is pointing to var. Okay, ptr is the logical representation, is the logical meaning is ptr is pointer is pointing to a variable. Now since pointer is also a variable, it will have its own address. Okay, so 9001 here is the address of the PTR because it is also a variable. Okay, now please note this PTR here can hold only address. The var here can hold only a number. Please note this 5001 is looking like a number, but it is not just a number, it is an address also. It is an address. 25 here is not at all an address, it is simply a number. Okay, fine. I hope you have understood this. Okay, let's continue and write a program. Yes, int let's take say double. Okay, because double is of size 8 bytes. Okay, so double D equals some 5.5. Please note I'm not giving F. If I give F, it will become float, which is 4 bytes. So let it be 5.5. Okay, now to store the address of this variable D, I need a pointer of type double itself. So star P equals null. This is how we initialize pointers, that is using null. Okay, using null. Please note null should be in uppercase letters. Okay, and then a pointer whose value, okay, we will write it here in the notes. Yeah, we'll write it here. A pointer whose value is null, that is a pointer holding null, okay, whose value is null, is called as null pointer. Okay, its meaning is that it doesn't point to any variable. See, at the beginning, at the declaration of a variable, we will not be knowing its value immediately. We may or may not be knowing its value, isn't it? So we have to initialize it with some default value. If it is integers, we use 0. If it is character, we use null character, that is /0. If it is double or float, we use 0.0. In the same way, if it is any pointer, we use null. That is very simple. Okay, all right. So I hope you are understanding this. Okay, now let's go to the a pointer whose value is that I have written there in the notes. Okay, so now what I'll do is P equals ampersand D. See, whenever you have a assignment operation, what you have to do, you have to check the assignment is correct or not. Okay, right? So for that, what you have to do, you have to check the data types on either side. So check the data types. See, on the what is the data type of P? Double star. Okay, it is evident from the declarative statement, that is line number 9 here. And on the RHS, what is the data type? It is double star only. Okay, see, if at all I had written only D, it would have been simply double. But address where a double is present is address, and address where double value is present is double star. So double star equals double star, which is correct. Okay, so now let's continue here. So here what we'll do is printf value of D equals %LF. Please note the variable D here is of type double. So the format specifier that we should use is LF. Now how do you print a value of a variable? Simply take the name of a variable, say D. That's all. That's all. Okay. So what it will print? 5.50000 it will print. Let's check it. Okay. So value of D is 5.5 followed by 5 zeros. Okay. Okay. Next what I'll do? Value of D itself I'm printing. Okay. So what I can do is, please come to this. See here, when I apply star to this address 1001, okay, what we get? The value present in that address, that is 10. Okay, I'm sorry. Yeah, let's continue. Here, to get the address of this variable num, I simply prefix ampersand. So what do you get? The address of the variable. So now what happens if I say star ampersand num star ampersand num? The num is 1001. Apply star to it, you'll get 10. So shall we do it? Okay, where it is here, I'll say here star ampersand num. Okay, right? So when you do this, what do you get? Yes, it is not num, sorry, it is D, right? Okay, see, value of D is 5.5. How come? What we did, come again, we said star ampersand D. Okay, it is num. So now num, to get its address, what we do, we apply ampersand. So you get 1001. Now apply star to that address, that is 1001. What is star? Dereferencing. What do you mean by dereferencing? Dereferencing is fetching the value present in the address. Very simple. Okay. So what is value present in the address? 10. In the same way here, okay, to get the value of a variable, what we can say? Star ampersand D. Okay, ampersand D means we'll get the address, okay, and then apply star to it, you'll get its value. Now next, address of D equals, see, I'm using percentage U, or you can use percentage X. See, address will never be 5.5, 2.3. See, we don't have any door numbers in the okay, we have the door numbers as a whole numbers only. Okay, so please note, I am printing, in this case, please note here what happens is, this is definitely a floating point value, okay, but its address, say assume 2002, is not a floating point value, is not a double type of value, it is a whole number. The addresses are always whole numbers, okay, whole number, WHOLE, whole number, okay, right, isn't it? Okay, it is real, it is natural numbers that starts from 1 2 3, it doesn't start from 0 1 2 3, okay, right? So 2002 here, to print this number which is always positive. See, one more thing is why I'm using percentage U there is, okay, there are chances of negative numbers getting generated if you use percentage D. For that you have to know the range of percentage D and percentage U, okay, right? So since they are of integers, I mean, there these format specifiers percentage D, percentage U are used for integers, so 4 bytes would be considered. But sometimes the addresses will be very big numbers. To store them, we need 8 bytes. So in that case, if we are using percentage U, which is of 4 bytes, so there might be chances of percentage D if we use, there might be chances of negative numbers getting printed. So see, the addresses nowhere in the world is door number -50, door number -100. We don't have like that. So we should, it is good to use percentage U or percentage X. Okay, if you use percentage X, there is the address given by the OS itself will be sometimes printed. Okay, yeah. Now let's continue here. Very simple. What we are printing? Address of D. Okay, I explained you so far why we are using percentage U. Okay, percentage LF is to print the value of the variable but not the address. Okay, I hope you have understood this. So now here the address of any variable is simply ampersand variable. What is the variable here? D. So please note, to get, assume the things in your classroom now, like say there is a fan, there is a chair, there is a bench, there is a screen, etc, etc. So assume they are all variables. So to get their addresses, what do you do? Simply prefix ampersand. Ampersand chair, ampersand fan, ampersand switch, ampersand door, ampersand bench. Okay, so what do you get? The addresses of these variables. Okay, right. So now let's run this. See, the address of D is some number here, as you can see. Okay, all right. Okay, yeah. Now what we'll do? Now, as you can see, the pointer P is pointing to D. Correct? Pointer P is pointing to D. So what we'll do here is we'll write okay. See, this is variable D and this is pointer. Okay, I'm sorry. So this is D. Assume its address is 2002. I'm sorry. This is 9001. Assume its address is 9001. This is P. The pointer P. So what is its value? 2001. That is the address of D. What is the value of this? 5.5. So what it is? P is pointing to D. Okay. All right. Okay. So these diagrams, they play a very important role, which you have to note down them. Okay. Now let's continue. So here what we are printing? The address of D I have printed, but please note I can print it using P also. Okay, right? Now check it. So address of D, can you check it? It is, I'm saying ampersand D here, and here I'm saying P. Okay, right? Okay. Now using what we have printed this, that also will say. Okay, right? So D means 5.5, star ampersand D means 5. Ampersand D means its address. P means again the address of D. Okay. Now if I want the value of D, okay, right? But I want it through P. I want it through P. So what I can say, star P. Okay, right? Star P, isn't it? Right. Run this. See, star p when I'm saying I'm getting 5.5, which is value of d. Okay, how did it happen? How it happened? Let's see. Now here, please note, I said star p. Star means what? Value at. P means what? 2001. Okay, name of the variable, you will get its value. What is 2001? An address. Whenever you get an address, so let's reach. So we are here now. Now apply value at. Value at is what? Value at for 2001 is 5.5. So write it. 5.5 is what? Nothing but d. Isn't it? So come again. Star p is what I said to get the value of d. So star p when I said, what is star? Value at. That is dereferencing operator. Okay. So dereference we are saying value at p means its value. Okay, 2001. So value at 2001 is 5.5. Okay, I hope you have understood this. Okay. Just a moment. Yeah, sorry for the inconvenience. All right, so now let's continue. I hope you are trying to understand. Okay, now what we'll do, we'll print the address of p itself. So address of p equals percentage u. Okay, please note, to print the address we use percentage x or u. Okay, right? So here what we'll say, ampersand p. Okay, and here what we'll say, ampersand p, right? So ampersand p means its address. So see that the address of p is, okay, right, it is something different than the address of d. Okay, right? I hope you are understanding this. Okay, right. Okay, yeah, so now let's run this again. See, the address of p now became 3312. Can you see that? Okay, and the address of d became, when we are trying to print the value of address of d. Okay, so as you can see, it's all simply virtual addresses. They are not actual addresses where variables are stored in the RAM. Okay, they are only virtual addresses. Virtual addresses means addresses which are created by the by some programs for us. Okay, right? So what is the need of these addresses? It will help us in our program, okay, for many applications. Okay, now let's continue. Yeah, I'll continue with this program. So now what we will do is printf will print the value of p. Okay, right, value of p, very important. Value of p, what is the format specifier? It is percentage u or x. Why? The value of p is nothing but an address. See, the value of p is an address. Okay, very simple. Value of p is an address means p is a pointer. That's it. Okay, because pointers hold only addresses. That's very simple. Okay, so let's run this again. See, value of p is the address of d. Can you see that? Address of d is 320, which is the value of p. Okay, right? I hope you are trying to understand. Okay, now you can say value of p as, see, I'll say value of p equals, okay, I'm sorry, value of p equals ampersand d also. isn't it? Because ampersand D, which is the address of D, value of P, which is the address of D, that is 2001. Okay, address of D, that is 2001, is value of P. Okay, so this is very important for you to understand. P here is a pointer, okay, and it will hold an address of some other variable, and that's it, what it does. Okay. P here cannot 5.5, 10.5, okay, because they are not addresses, and pointer can hold only addresses. So run this. So value of P equals, okay, ampersand D. I'm saying value of a variable. If you want to print, you have to simply take the name of the variable, that's it. Okay, isn't it? Now recall our first few programs that we did. Int x equals 10, y equals 20, z equals 30 when we said, and when I want to print the values of x, y, z, what did you say? Printf percentage d x, printf percentage d y, isn't it? So what did you get? The value of the variables x, y, z. So here the value of is nothing but the address of d. Okay, so I hope this program was understood by you, and it is very important. Okay, all right. Now let us move on and learn pointer to a pointer. Okay, pointer to a pointer. Now I'll take the same example. See here, now what is pointer to a pointer? A pointer pointing to a pointer. In other words, a pointer holding the address of a pointer. Okay, so nothing but if I want to store the address of P here, that is 9001. Okay, right here, say, since this is also a variable, okay, right, so we will have its address, say 7001. Okay, right. So now what is this? PP. Let us name it as PP. Okay, so this is pointer to a pointer. Okay, right. So this is pointer to a pointer. Okay, all right. Now PP is pointing to P. Now come here. What is the data type of D? Double. Okay, what is the data type of 2001? Double star. Okay, what is the data type of P? Double star. Okay, very important, you must know this. What is the data type of 9001? It is double star star. This is what you have to understand. Okay, right. So please note, where a value of type double is present, its address is double star. Where a value of type int is present, its address is double star. I'm sorry, int star. Okay, where a value of type double star is present, its address is double star star. Okay, so what is this? Double star star. And what is this? 7001? Double star star star. Okay, this is very important. I'm sorry. I hope you are trying to understand this. Okay, this is very important. Okay, now let us continue and declare a pointer to a pointer. Okay, so double star star. Okay, double star star pp. Okay, equals null. Okay, right. Now please note, pointer to a pointer is also simply a pointer, isn't it? Right, because it also holds the address of a variable. So which variable address it holds? It holds the address of another pointer. It holds the address of a pointer. Okay, now further let's continue. Here what we'll do is see, please note, you can declare variable pointer like this, okay, or like this also, okay. But when you are declaring multiple pointers in the same declarative statement, it's better to give star, okay, to the variable, not to the data type, okay. Here p is made to point p, pp equals ampersand p, okay. So what you will write here, pp is made to point p, okay, right? I hope you have understood, okay, right. So now what we'll do is we'll copy this, okay. So for time being we'll remove this from here, okay. So what program is this? Program to understand the work of a pointer, okay. So next program will be program to understand working of a pointer to a pointer. This is understand the working of a pointer. I'm sorry. Now what is a program? Program to understand the working of a pointer to a pointer, okay, right, okay. So in that case what we'll do, we'll remove this, okay. Now what should be on your mind? This diagram. So please try to understand this diagram for a while. I'm giving you 30 seconds of time. Okay, so now next let's continue here. So whatever we want now, I mean the printf statements that I'm writing, okay. We'll write it in terms of pp. We'll write it in terms of everything in terms of pp, okay. Please note p is about p, and through p we can also reach d, okay. And hence what we'll do now, address held by pp equals percentage u, so it is pp, okay. That is the address held by pp. Whose address it is? It is the address of, it is the address of p, isn't it, right? See, the address held by pp is 9001, which is the address of p, okay, right, right, isn't it? The address held by pp, that is pointer to a pointer, is that of the pointer p, that is 9001, okay. So what we will do here, we'll say pp, okay. So now next here what we'll say, address of p equals, address of p equals what? Address of p is nothing but ampersand p, but the address of p we have it in pp also. See, address of p we have it in the pointer to a pointer, okay, right. So it is simply pp, isn't it, right? Now next what we'll do, value of pp equals, value of pp equals percentage u. Okay, nothing but pp. Okay, right? So now let's run all these three. See, it is the same address. Okay, address of p it is, isn't it? Okay, in our case it is 9001. All right. Okay, now next. Now what we'll do is yeah, address held by p. Okay, address held by p is star pp. Okay, right? So what is that? Address held by p is what? See, address held by p is 2001. Now to how to get it through pp? Pp, when you say 9001 you'll get, so you'll reach here, that is the address of p. Now dereference it. Dereference it. What do you get? 2001. Okay, dereferencing means value at. So value at, when you say pp, value at pp means pp is 9001, so you'll get this. Okay, so now value at 2001 is 2001. Please note, value at pp, that is star pp, means first you have to get what is pp. What is pp? 9001. Correct? Now apply star 9001, you'll get 2001. I hope you have understood. Okay. Now address of d equals, okay, address of d is nothing but value of p. Address of d is nothing but value of p, which is star pp. Correct? Okay, so again value of p. Okay, so run this again. Observe the last three. Last address held by p. Okay, address held by p it is, okay, is 3312. See, address held by p is 3304. Okay, okay, address held by pp. So whose address it is? It is the address of p. Now address held by p is the address of d. Address held by p is the address of d. Okay, so what you have to do? You have to constantly, continuously look at the diagram. Continuously look at the diagram and you can understand. Okay, all right. Okay, fine. Now next we'll continue here. Address held by p is 3312. Okay, yes. Now let's continue. Value of d equals, okay, star pp. Okay, value of d equals star pp. How come? Run it. See, value of d equals 0 it is saying. Yes, we should use percentage lf. Yeah, see, value of d equals 5.5. It is star pp. So how does this happen? How it happened? Let's see. See, star pp. What is star? Value at. Again, what is star? Value at. There are star 2 times. Okay, so pp means 9001. Okay, so value at, what is value at 9001? 2001. What is value at 2001? 5.5. What is 5.5? It is d. Okay, I hope you have understood. Okay, all right. Now lastly we can say address of pp. What is address of pp? Ampersand pp, isn't it? Right, that is nothing but from the diagram what we want? 7001. Okay, right. So what is that? Let's check. See, address of PP is 3304. Okay. Address of D is 3320. Okay. Address of P is 3312. So can you see that? They're all different addresses, isn't it? Because they are different variables, so their addresses must also be different. Okay. Right? Okay. So I hope you have understood this. So let's copy this and I'll paste it here. Okay. Right? So this is a pointer to a pointer. Now next program will be, our next program is program to understand pointer arithmetic. Okay. Program to understand pointer arithmetic. Okay. Now let's continue. Let us take a new program. Okay. Let us take int num equals 10 and int star p equals ampersand num. Okay, so now this is very simple, as you can see. Now here what we'll do is we'll say printf address of num equals %u ampersand num is what I'll say. Okay, right? Okay, so before that what we'll do, printf value of num equals %d. So how to print it? Say simply num. Okay, run this. So value of num equal, it is printing. Okay, value of num is 10. Very simple. I have printed the value of 10. Okay, right? Okay, so now what I'm taking, this is num and this is p. Okay, right? Num is 4 bytes, p is 8 bytes on my system. Okay, that is pointer. Okay, what is its address? Say 1001. Okay, what is its address? Say 2001. What is its value? Say 10. What is its value? 1001. So what is the meaning? P is pointing to num. Okay, so these diagrams, they are very important for you. Now please note, what are all the addresses of num? 1001, 2, 3, 4, 1004. What is that? Where I can store next integer value? Only in address 1005. Can I store any integer value before 1005? No, impossible. Okay, what is the previous address of num? 997. Okay, right? It is 997. Okay, why? 997, 98, 99,000. Okay, these are the 4 addresses of the previous integer variable. Okay, right? Okay, all right. So now next let's continue. Now here, come to this value of num equals. Okay, so now what we'll do is, now that you have understood this, num equals %d, comma num plus 1, okay, equals %d. So what we'll say here, num plus 1. Okay, so run this. As it is expected, num equals 10, num plus 1 equals 11, isn't it? Okay, however, what now we will do is, what I will do now here is, I'll say ampersand num, so I'll use %u, and here ampersand num plus 1. Okay, so here it is ampersand ampersand. So let's check. So please check, the address is 3316. So 16, 17, 18, 19. These are the 4 addresses of num. So the next address of the address of next integer is 3320, isn't it? Right. Okay, so the address of next integer is 3320. Okay, I hope you have to understand this. Okay, all right, now let's continue with this. So here what we'll do is we'll add one more ampersand num minus 1 equals percentage u. Okay, so here what we'll do, ampersand num minus 1. Okay, right, so 312 3316 3320. All right. Okay, so there is a difference of 4 bytes. Now here when you say num minus 1 equals percentage d, okay, so num minus 1 is 9 10 11, but when you do the same arithmetic you are doing, okay, right, so the same arithmetic when you are doing on addresses, it is jumping 4 bytes. This is what you have to observe. Okay, so addresses are not like mere numbers. So please note, when you said ampersand num plus 1, you did not get 3316 plus 1, you did not get 3317, you got 3320, isn't it? 3320 you got. Okay, right, so why is that? Is what is the meaning is ampersand num plus 1 means it is saying address of next integer. Okay, ampersand num minus 1 means address of the previous integer. Okay, so here num plus 1 means next integer value, num minus 1 means previous integer value, which is 9 and 11. Okay, so what you have understood here is that every address has, okay, every address has a characteristic called as length or size of the data type property. So this is very important. Okay, right, so addresses are not simple numbers, simply numbers, they're not just numbers. You have understood. Okay, right, so now let's have a recap what we have learned today. We have learned pointers today. Okay, in pointers we have also learned pointer to a pointer. Okay, so in the case of pointers, what are the things that you have to note? Pointer is also a variable because it also holds some values, but please note the values held by pointers are nothing but addresses. They cannot store anything other than addresses. Next, a pointer irrespective of the data type, its size will be same. Meaning to say, you take hundreds of pointers, every pointer is of unique data type, but their sizes will be different. Sizes will be same. Okay, this is what we are going to, I'm going to show it to you in our next class. Okay, and then a pointer of a specific data type must point to the same data type. What is the reason here? This is the reason, okay, which I'm going to again continue tomorrow. And today I have also taught you that a pointer address can also be held by pointer to a pointer. Now, who will hold the address of a pointer to a pointer? Okay, if I want to store the address of a pointer to a pointer, then I need pointer to a pointer to a pointer. Okay, and so on. All right. Okay, fine. And then we have also learned, you know, with the help of the pointers, the physical view, that is how it looks like in the memory I have shown you. And what is the logical meaning? The logical meaning is that the pointer points to a variable. Okay, here this arrow mark, that is what the meaning is, but actually what happens is the pointer holds the address of the variable. Okay, right, All right. I hope you have understood pointers like never before. Thank you all. Tomorrow I'm going to continue with pointer and then I will solve some problems on arrays. And if possible, if time is permissible, then we'll try to solve some problems on strings also. Thank you very much.